This particular set of slides is about how to determine a study's design. I'm going to go through this with a few things in mind. First, I'm going to be testing over this later, but second, I also want you to factor in your own design for Phase 4 as one of the components of Phase 4. So keep in mind this applies to that as well. We use a specific notation system when talking about our design. I'm going to go through the different pieces and then I'm going to go through an example of what that looks like. So first of all, you have to figure out how many independent variables you have in your study. And then you have to identify the type of variable that you're working with. Is it between participant? Is it within participant? You have to do this for each of the variables in your study. You also have to identify which of your variables is randomly assigned. And then you also have to clarify how many levels you have for each variable. What do I mean by that? For example, if you had gender as one of your variables and you were measuring it using its simplest binary form, then you would have 2 levels, male and female. If you had a drug as one of your variables and you were administering either 0 milligrams, 50 milligrams, or 100 milligrams, then there would be 3 levels to the drug variable. We're going to go through the simplest version of this, which is fully crossed. A fully crossed design is where all the variables combine with one another in every possible combination. There are more complicated versions of this that are not fully crossed, but for our purposes, we're going to keep it simple and keep it at its most basic, and consider designs to be fully crossed unless otherwise said so. What this means for your study is that if you had 2 variables, then every single possible combination of those 2 variables would be present in your design. I'll go through an example of what that looks like in just a little bit. If there's more than one variable, then you provide the number of levels of one of your variable, and then an X, and then the number of levels of your other variable. Once again, we're going to go through some examples. We'll build up to it. But it would be the number of levels of variable 1 and the number of levels or groups in variable 2. For example, a study that has 2 variables that each have 2 levels would be considered a 2x2 design. This should look familiar from statistics class because when we learned about two-way ANOVAs, we talked about 2x2 designs. If all of your variables are between participant, then you have a between participant design. If all your variables are within participant, then you have a within participant design. And if you have a mix of between and within, it's known as a mixed design. Keep in mind that if you have a pre and post test as part of your study, that would be a within participant variable with 2 levels, pre and post. We're going to talk about a very straightforward design where the researcher is looking at the effects of both gender and drug on self-esteem, which is a similar example to what we went through a lot in statistics. There are different groups of gender, either male or female, and there are different groups of drug. People either take 0 or 50 or 100 milligrams of the drug, which makes them both between participant design. The drug condition is randomly assigned, and gender, of course, is pre-assigned. People come in with a certain gender in mind already. In this particular case, I've got 2 variables, gender and drug. Gender has 2 levels and drug has 3 levels. So I would call this a 2x3 between participant design. And this is once again an example of a fully crossed design. So I can assume that half of my study is male and half of my study is female, and that within the males, a third of them have 0 milligrams of the drug, a third have 50, and a third have 100. And same with females. A third have 0, a third have 50, a third have 100. That all males and females experience at least one of the levels of drug in combination. Does that make sense in terms of fully crossed design? I hope it does. It's also important that you label the different groups when you talk about the study's design in, for example, a paper. So in your Phase 4, I expect you to have a design statement using the notation system. Let me go ahead and show you what that would look like. So here is the notation system at work. You might notice, once again, the rules apply with parentheses. If you remove the parentheses, the statement still makes sense. It would read, this study is a 2x3 between participant design. The drug condition is randomly assigned. This includes all the information that we need, and then within parentheses we further label in terms of how we're naming the variable, gender or drug, and the different levels of that variable, male versus female, 0 versus 50 versus 100 milligrams. So you can see how you might have a design statement written out in English that clarifies the type of design that it is, how many variables you have, the different levels of each variable, and what we're calling everything, as well as what has been randomly assigned. This, of course, is a flexible system. So if you add a level, then you would change the number. So for example, if you had a gender and drug study where participants were taking 4 levels of the drug instead of 3, it would simply be a 2x4 design instead of a 2x3 design. And of course, you could add other variables as well. You don't just have to have 2 variables in a study. If, for example, you were looking at males and females who were taking 0, 50, and 100 milligrams of the drug, and you were also taking a look where half of them were 10 and half of them were 15 years old, then that would be, if you'll follow, a 2x3x2 between participants design. In this particular notation system, you can multiply the numbers out in order to determine the total number of combinations when you have a fully crossed design. So in the case of a 2x4 between participants design, there are 8 total combinations, males who take 0, 50, 100, and 150, and females who take 0, 50, 100, and 150. In the case of the example below with a 2x3x2, there are actually 12 different possible total combinations. So you can see how that would factor in a fully crossed design.